Hey everyone, in today's video we're going to be learning how to convert binary numbers to a base 10 or a standard number system. So before we get started we have to learn what is a binary number. So what is a binary number? So a binary number is a number system based on the base 2 system. So it's based on base 2 system. So normally in our number system we usually have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is usually our base 10 system for representing digits of numbers. For example, if we want to represent 100, we would use the 1 right here as the 100th place, and then we would use a 0 and a 0. This would be 10 to the power 0, 10 to the power 1, and this would be 10 to the power 2, respectively. So what we would get here would be 10 times 10 to the power 2 is 100, plus 10 to the power 1 is 100 times 0 is 0, and then plus 10 to the power 0, which is 1 times 0 is 0. So that would be 100 right there. So that's how we would represent 100 in our base 10 system. Now what if we want to represent binary number system? Well, binary number system uses only the digits 0 and 1, base 2 system. So you may be wondering, well, how do we represent huge numbers using the base 2 system, binary system? Well, there's a secret technique. So usually a binary system has 7 digits or 7 bases. So we'll just go ahead and put 7. 1, 2, 3, 4, 5, 6, 7. Oh, this is way too much. All right. So let's go ahead and write the numbers 0, 0, 1, 0, 1, 1, 0. So you may be wondering, what do all of these ones and zeros mean? Well, just like our base 10 system, binary system is a base 2. So we'll go ahead and write 2 to the power 0 right here, 2 to the power 1 right here, 2 to the power 2 right here, 2 to the power 3 right here, 2 to the power 4, 2 to the power 5, and 2 to the power 6. So just like how we calculated using the base 10 system, we're going to do the same thing with the binary system. So let's go ahead and convert all of these numbers into base 10, which is our normal system. So we'll start from this side and we'll move our way from right to left. All right. So let's use a different color. So what is 2 to the power 0? Well, 2 to the power 0 is 0. So wherever there's a 0, we don't really have to count that value because anything times 0 is, well, 0. So anything with 0 we technically don't have to count. So we'll not count this value, we'll not count this value, this one, or this one. We mainly have to focus on these values right here. Don't change the order, we just don't have to calculate using these zeros values. So what is 2 to the power 1? 2 to the power 1 is 2, alright? What is 2 to the power 2? Well, 2 to the power 2 means it's 4. 2 to the power 4, well, that's 4 times 4, which is 16. Now all we have to do is add these values. So what is 16 times, or 16 plus 4 plus 2? Well, that's just 22. So the representation of 0, 0, 1, 0, 1, 1, 0 in binary number system is the number 22. So I hope you see how that works. Let's go ahead and try a different example. So let's go ahead and just put some random numbers or lines right here. I'll go 1, 0, 1, 1, 1, 0, 1, 1, 1. Alright, so now let's go ahead and find out which ones have zeros. So we can see this one has a 0, so we don't count this in our addition, and this place has a 0 too, so we don't count a 0 there. Alright, 2 to the power 0 right here, 2 to the power 1, 2 to the power 2. So I like writing the 2 to the power of the place number because it helps me calculate my addition much easier. So this would be 2 to the power. Oh no, we hit it wrong right here. So you gotta be careful because as you can see here, we skipped 2 to the power 1, so this would be 2 to the power 2, but we're not using that, so it would be 2 to the power 3, 2 to the power 4, 2 to the power 5, and 2 to the power of 6. So let's go ahead and, I made a mistake again. We gotta go 2 to the power 6 right here, 2 to the power 7. So we're not going to count 2 to the power 6. So we'll go ahead and do 2 to the power 7, which is 128, plus 2 to the power 5, which is 32, plus 16, plus 8, plus 2, plus 1. So if we were to go ahead and add all these out, we would get 128 plus 32, which would be 60, 160 plus 16 less 176. 176 plus 8 would be 184, 180, 186, 187 is the final answer of this binary representation. So I hope that makes sense to you. Thank you so much for watching this video, and if you have any questions, don't hesitate to leave them in the comments below, and see you next time.